Hi, Upward Bound. Welcome to Math Analysis Day 1. Today we're talking about complex numbers and quadratic equations. So a complex number is the number I. Complex numbers are of the form a plus bi, where a and b must be real numbers. I squared is equal to -1, therefore the square root of -1 is equal to I. The real number a is called the real part and of a plus bi, and b is the imaginary part of a plus bi. So essentially, when dealing with complex numbers, you treat I like x. So if the square root of -1 is I, then I squared is -1, I cubed is -I, and I to the fourth is 1. The sum of complex numbers simply means you add the real parts and you add the imaginary parts. So when you are given 2 plus 4i plus -1 plus 6i, 2 minus 1 and 4 plus 6 gives you 1 plus 10i. The difference of complex numbers, again, you subtract the real parts and you subtract the imaginary parts. So in this problem, 3 plus I minus 1 minus 2i, it's almost like combining like terms. You end up with 2 plus 3i. Be careful when you subtract a negative. The products of complex numbers are a little bit more complicated. Again, you distribute. You think of I as being x, and you distribute. So we multiplied the inside, we simplified the inside, we finally got down to I squared, so that when we write it in the correct form, it would be 1 plus 8i. If z is equal to a plus bi, this is a complex number, and its conjugate, denoted by z bar, would be a minus bi. We simply change the sign to achieve the conjugate. We need the conjugate when we do division. So the conjugate of 3 plus 2i would be 3 minus 2i. So the theorem says that if you multiply a number and its conjugate, you simply then get a squared plus b squared. So the square of the real part plus the square of the imaginary. So when you're given this problem, we will multiply the top and the bottom by the conjugate of the bottom. Simplifying, distributing through absolutely everything, we do end up with a -4/13 minus 7/13 I, and it does need to be written in a plus bi form. If n is a positive real number, we'll define the principal square root of -n as I square roots of n. Essentially, when you take the square root of a -1, it comes out as an I. In the complex number system, the solution to a quadratic equation, ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and are given by the formula, the quadratic formula, where a cannot equal 0, x is equal to the tune of Pop Goes the Weasel, x equals -b plus or minus square root b squared minus 4ac all over 2a. You'll need to memorize that. The discriminant of the quadratic equation is b squared minus 4ac. Okay, this is called the discriminant. If that is greater than 0, there are two unequal real solutions. If it is equal to 0, there is a repeated real solution, meaning you have 4 and 4. And if the discriminant is less than 0, there are two complex solutions, and the solutions could be conjugates of each other and should be conjugates of each other. So, solving this equation, A is 2, B is -2, and C is 1. This is not factorable. You must use the quadratic formula. We can figure out that the discriminant would be a -4, which does mean it is less than 0, so there are two unreal or imaginary solutions, giving us 1/2 plus or minus 1/2 I. Thanks for watching. You're going to do an assignment in class.